Okay, assuming you've already worked through the work on test 3, this example will look very familiar. We've seen this data before. Last time we did a sign test on it. We're going to contrast the sign test with the Wilcoxon sign rank test. And we'll see that the Wilcoxon test makes an additional assumption, but is better able to pick up information from the size of differences. So, working with this data that we've seen before, last time we didn't have any evidence that the shopkeeper was wrong about the belief that the median was 0. Our hypotheses are going to be the same, are going to be in terms of the population median. Important you include this word population. So the null hypothesis is going to be, well, the shopkeeper believes that the median is £20. Says mean in the question, but because this is Wilcoxon, we're assuming everything's symmetrical, so the mean and the median will be the same. You can get away with just saying median every time. The alternate hypothesis is, well, the shopkeeper's belief is not a one-sided belief. She believes it is £20, so the opposite of that is simply that the population median is not £20, rather than being greater than £20 or less than £20. So we have a two-tailed test and not a one-tailed test. Okay, so to conduct the test statistic, so step 2 is the test statistic. Now for the Wilcoxon signed rank test, what we need to do is firstly find the magnitude of the differences with the claimed median. So we have to decide which side of how far on which side we are. So with the 5.57, that's below the median. So if I take away 20 from that, I'm going to get a negative value. I'm going to get minus 14.43. So I do that for all of these values. When I take away the £20 from this one, I'm going to get 1.95. From this one, I'm going to get 15.70, and so on. So for negative answers, that means that the customer was spending less than the claimed median. So having worked out all the differences, I now need to rank these differences in order of size. So the ones that are a long way away from the claimed median are going to count more heavily in the calculation than the ones that are really quite close to the median. So looking at these values, the smallest one in size, which I'm going to give a rank 1 to, is the 0.99. So that's a +1. Okay, and then looking at the next biggest, I've got two differences of 1.95. Okay, one's positive and the other's negative, but they're both equally ranked. So this is ranks 2 and 3. So I need, as we did with the Spearman, I have to give them both a rank of 2.5. So I deal with tied ranks in exactly the same way. Moving upwards from £1.95. I think I've got a £3.51, so that's rank, just use 2 and 3, so this is rank 4, and it's a positive. And then I've got a £5.17, that's rank 5, that's a positive. And rank 6 is also a positive. Okay, and then I've got a negative in rank 7. And after £7, I've got a negative at rank 8, 24, 12.45. And then the next biggest one is another negative, and that's rank 9. And then all of the remaining ones are, so this is going to be rank 10 and 11 and 12, but all of those are positive ranks. Okay, so I've now got the positive ranks and the negative ranks, and my test statistic T is going to be found by totaling the ranks with positive signs and totaling the ranks with negative signs and choosing the smaller total. So I think I can see that smaller total is going to be for the negative ranks, but let's just check to be sure. So for the negatives, we're going to have 9 plus 7 plus 8 and then plus 2.5. And that's the total of the negatives. So these all add up to 16, 24, 26.5. And for the positive ranks, that's going to be all of the other ones added up. So 2.5 plus 10 plus 8 and so on. So that's 12.5 plus, oh no, so the 8 is not positive. So that's 12.5 plus 5 is 17.5. So that's going to be 29.5. This is going to be 33.5. This is going to be 44.5, 45.5 plus 6 is 51.5. So as we expected, the total of the positive ranks is quite a lot bigger than the total of the negative ranks. Now, when I go to the critical value, which is going to be my next step, there is some help on this page. So it tells us that we need to sum the ranks of observations with the same sign. And it tells us that the upper one is going to be this value here minus the lower one. So we can always work with the lower tail. That's why we take the lower value. But we can use this as a check. If we have worked out both totals, then I should be able to do a half n times n plus 1 minus one of my values to get the other value. So let's try that out. So a half n times n plus 1, n is the number of pairs of observations, or number of columns in the table. I've just got single observations. So in this case, n is 12. There were 12 customers. So it's a half times 12 times 13, which is a half of 156, which is 78. And if I do 78 minus 26.5, you can check this, I do indeed get 51.5. So these two do add up to 78, which they should do. So that's a not bad check that you've done your adding up correctly. Okay, so if you have time in the exam, that's a nice check to do. All right, but we need to now take the one that will be tabulated, if anything. So the one that will come from the table, we saw that was the lower values used in the table. Okay, am I doing a one-tailed or a two-tailed test? Well, it's two-tailed. So on my tables, the two-tailed line is here, and I'm doing a two-tailed test at the 10% level. And I need to look at my n value. There were 12 pairs of customers, so I need to come down here, and I need to look under two-tailed 10%, which means that the critical value at the lower tail is 17. Okay, so 17 values and below, okay, because this is the lower tail. All right, so 17 and below would be critical values. So my critical value, which is my step 3 of my process. So the critical value from the table with n equals 12, and it was 10%, and it was two-tailed. So that's the work I did from the table, equals 7. So that's my critical value. Sorry, 17 it was, wasn't it? And I need to compare my 26.5 with my 17. So this is clearly greater than. Is it significant or not? Well, we're looking at the lower tail here, so it would be a significant answer if my lower total was so low that it actually got into this tail, but it's not that low. It hasn't succeeded in being significant, so this is not significant. Okay, at the 10% level. So we are still going to accept H0. Okay, and so my conclusion in context is going to be there is no evidence at the 10% level that the median is not £20. So therefore we're going to be accepting the shopkeeper's claim or belief. It's a belief, isn't it? Okay. I had to make an assumption. We always make an assumption with the Wilcoxon signed rank that the distribution is symmetrical. So we have to assume the population distribution is symmetrical. All right, and that because it's symmetrical, a consequence of symmetrical distributions is the median and the mean are the same thing. So what I've been playing it safe, I've been talking about the median, which is perfectly correct and also would be correct for the sign test. Okay, and median here and here. The question actually referred to the mean. And the mean is the same thing as the median if I assume that the population is symmetrical, which I have to do. So if you see the word mean in a Wilcoxon question, then it means the same thing as median because the distribution has to be symmetrical. So you can treat the word mean in these questions as meaning the same thing as median. You can carry on using the word median as normal. this solution would be perfectly correct if I changed the word median to mean, but you wouldn't want to do that for a sign test, and therefore you're best off on both of these tests talking about the median. You don't have any tests specifically for a mean in S3, so stick to the word median would be my advice. Okay, and then to finish this question off, we're invited to compare what's happened here to what happened in 3.1, where I had exactly the same data. The comparison I ended up doing on that occasion was 0.3878 with 0.1, so the test statistic really woefully failed to be significant. This time it's still not significant, but it's actually come a little bit closer, and that's because the Wilcoxon method has allowed the fact that I've got some really quite big, hefty positive differences to come into play. So these top three, the three biggest differences were ranks 10, 11 and 12. Okay, and those numbers counted as 10, 11 and 12 in this number, and the ranks for the negative ones were all sort of tended to be the lower ranks. So the Wilcoxon test has taken into account the fact that the difference is a little bit bigger for the positive differences than for the negative ones. But that wasn't enough to change an inconclusive result into a result where we concluded in favour of H1. So we had the same results, so there is the same outcome, although the comparison seemed closer. Okay, and that finishes that question.